OK, and now the fun part begins. So now we're going to show that the evil Turing machine is impossible. So the way to see that it's impossible is to see that we get conflicting results when we look at the output of the machine and when we look at the results of our counting exercise. So by looking at the output of the machine, we can conclude this. We know that, and I'll explain it. So remember what the evil machine does. It just works on an empty input and delivers busy beaver of 2n plus 1. That means that the productivity of the evil machine is that. So we know of at least one machine with as many states as the evil machine that has that productivity. So if you now say, OK, what is the result of applying the busy beaver function to that many states? Well, we don't know what it's going to be, but we know that it's at least this. Because remember, the busy beaver function gives us the productivity of the most productive Turing machine with k states or less. So if that turns out to be the most productive Turing machine with that many states, then we're going to have an equality here. If there's another more productive one, then we're going to have an inequality. So we know that. OK, but now let's look at this result from our counting exercise. Because we know that, we know this. Because 2n is at least as big as that, and if you allow for more states, the busy beaver number is never going to go down. It can only go up. So that has got to be true. And then we're done, because these two are inconsistent. What in the universe could be cooler than that? So there can be no such thing as the evil Turing machine. So there can be no such thing as a Turing machine computing the busy beaver function. So the busy beaver function is not computable.